d bar is equal to 2x square yz ax plus 3xyz squared ay plus 4x squared y squared z ay az. I took all positive components only. I could have taken negative also. You know that. Just like that even. This is d bar at any point, so many coulomb per meter squared. Closed surface I am talking about. X is equal to 0, x is equal to 1. Y is equal to 0, y is equal to 2. Z is equal to 0 and z is equal to 3 are the surfaces. Find out integral d bar dot ds bar over the class closed surface. You do it. I will straight away write the integrals and then evaluate it. D bar dot ds bar, x is equal to 0 phase, x is equal to 1 phase, y is equal to 0 phase, y is equal to 2 phase. And x is equal to constant surfaces, that side goes from 0 to 2 in y, 0 to 3 in z. That's what you understood? Is that clear to you? When you write each phase separately, you will come to know that. Please put the integrals and see. I will also put, then you will know whether you understood it or not. Don't keep quiet. Please try. First integral, x is equal to 0. What is it? Integral z is equal to 0 to 3, y is equal to, integral y is equal to 0 to 2, minus of 2x squared yz because it is left face, sorry, hint face. At x is equal to 0 because of which dy dz, this is 0 straight away. Because when x is equal to 0 is substituted in this expression, it is 0. Everywhere this happens actually for y and z also. Plus integral 0 to 3 for z, integral 0 to 2 for y, integral 0 to 3 for z, 0 to 2 for y, d bar dot ax because of which it is 2x squared yz, at x is equal to 1 because of which it is 2yz dy dz, correct? X is equal to 1. 2x squared yz, but x is equal to 1 is not known to me for me. That 1 squared is 1. Plus integral 0 to 3, integral 0 to 1, three xy z squared minus of, because it is the left face. Because y is equal to 0, it is 3xy z squared at y is equal to 0, because of which it is also 0. Plus integral 0 to 3, integral 0 to 2, 3xy z squared on y is equal to 2 is what? 12xz squared dx dz. Understood? 3xy z squared y is equal to 2 is what? 6 only, right? Check it. On y is equal to 2 phase. Z is equal to 0, z component is 0. Because of which? Plus integral 0 to 2, integral 0 to 1. Last component is 4x square y square z minus of, because it is minus az, at z is equal to 0 dx dy. This is 0 plus integral 0 to 2, integral 0 to 1, z is equal to 3 in 4x squared y squared by z is what? 12x squared y squared dx dy. Evaluate it. 2 into 2, 4.
18.
9 by 2, 8. 4 into 9, 18. Ultimately, I'll put coulombs. What is this integral? 6 into x squared by 2 is 2, 12 into 9.
108.
What about this? 4 into y cube by 3. Correct? 4 into 8 by 3. Correct?
Yes,
Anna? Oh, 12. Correct. 12 into x cube by 3 is 4, 0 to 1. 4y squared is 4y cube by 3. Y cubed is 8 by 3. 4 into 8. 32 by 3. Correct?
Yes, sir. 32.
So total is 18 plus 108 plus 32 by 3. So many coulombs is the total charge enclosed by the closed surface that I have considered. Is it? Fourth term. Xz squared 0 to 1. Sorry. 0 to 1, 0 to 3. So it is 3 into 9. Very good, very good. 27. X limits are 0 to 1. Z limits are 0 to 3. In the expansions of the functions, we saw that f of x plus h is equal to f of x plus h into f dash of x plus h squared by 2 factorial into f double dash of x. You agree this? And f of x minus h is equal to f of x minus h into f dash of x. H is minus h plus minus and so on. Automatic. H can be positive or negative. But this is what we are supposed to know. Whatever we do here will be at least used in 10 places in different subjects as a crucial thing in the derivation. So please concentrate here. If h is very small, f of x plus h is equal to f of x plus h into f dash of x. Higher powers of h gets neglected automatically. If h is very small, h squared is very, very small, so that it is negligible. Never we consider delta x squared as some quantity, delta x cubed as some quantity. In the same way, f of x minus h is equal to f of x minus h into f dash of x. Okay? Listen carefully. And you are trying to concentrate. Given d bar at every point in a given region. Given d bar at every point in a given region, we can determine rho v at any point in that region. No textbook gives. I'm sure about my statement. Listen carefully if you want to understand and appreciate this topic. We can determine rho v at any point in that region, volume charge density. Can somebody tell me what is rho v at any point? At any point, what is rho v equal to? Volume charge density, how is it defined?
The limit delta V tends to 0 del Q by
Wonderful. Limit delta V tends to 0, delta Q present in that differential volume divided by delta V. Any doubt? At any point, if I know that there is charge density, I will calculate the volume charge density by consider, because at any point I can only consider differential volume, small, infinitesimally small volume around that point. Look at the charge inside, divide by delta V. Maybe I will draw it as a big volume. In Cartesian coordinate systems, that differential volume at any xyz differential volume at any xyz, the point is this, inside body center it is. That's how it looks. Listen carefully. Differential volume is what? Each of this side is delta x. Each of these horizontal lines are delta y. Correct only? And all the vertical lines are delta z. Consistent with Cartesian coordinate system. Given d bar, I want to find out the charge inside. Can I? Given d bar at any point, at that particular point, I have considered a differential volume. Definitely differential volume is delta x, delta y, delta z. You know that. Can we determine the amount of charge present in it given d bar? We are doing that business only now, right? Now, Listen carefully. Delta Q is equal to closed surface integral over the differential volume of d bar dot ds. You agree that now? They will ultimately define divergence like this. Integral of closed surface integral over a closed surface enclosing a difference volume divided by delta v, limit delta v tending to 0 is divergence, they call it. And I know that Q is integral rho v dv. I need to find out rho v through d. I want to do this. Given d bar is if d bar is equal to, now in general for me, dx ax plus dy ay plus dz az at the center, at the point. Listen carefully. Because the differential surfaces, they are all, no integration is required. If I know the flux density there at each and every phase, normal component of the flux density there multiplied by that area only is the integration for me. I need not integrate, right? Because there are differential surfaces only. D bar dot ds bar is equal to what? Integral over this closed surface. D bar dot ds bar is equal to, listen carefully. Hind face is at what distance from the center? Normal flux to hind face and front face is dx. At hind face, the normal component is dx only. But at the center, it is dx. What is it at hind face? Please check it. Dx minus dou dx by dou x f dash of that particular quantity only. I'm going just back from the center into delta x by 2. F of x I know, f of x minus delta x by 2 I want. Correct only, no? Dx ax dot minus ax delta y delta z. Check it once. Is the flux through hind face? D bar, I want to look at only x component because I want only normal component there. Y and z components are not important for me. Hind face, because from the center I will go f of x plus h, f of x minus h I told. H is either that x plus h or minus h. That h is delta x by 2 from the center, because each side, that side is of length delta x. From the center, hind face is at delta x by 2, front face is at delta x by 2. This is for the hind face. For the front face, dx plus dou dx by dou x into delta x by 2 ax into plus ax, right? Dot plus ax delta y delta z, front face. Please check whether it is clear. Is it clear? Y and Z components are not required because I am looking at only x is equal to constant phases. Only x component is important. And I am talking about this at a point. At the point which is at the center of this differential volume, x component of the flux density is dx. If I move by delta x by 2 back or front, I have to use this truncated expansion of the function, right? Taylor series expansion. For x. For left phase, what is it? dy minus, I will, from center, I will go along y-axis to the left. Dou dy by dou y, f dash of x, right? I told. Dou into delta y by 2 because I am going back. Ay dot minus ay because it is left phase. Delta x, delta z is the size of the phase. It is over the left phase. All are scalars now because dot product is there. Right phase dy plus dou dy by dou y into delta y by 2 into ay dot ay into delta x, delta z, right phase. For bottom and top phases, dz minus dou dz by dou z into delta z by 2 because I am going down in z, az dot minus az because outward normal is minus az into delta x, delta y bottom phase. Top phase dz plus dou dz by dou z delta z by 2 az dot az into delta x, delta y top phase. What is the sum of all these things? You should be able to see the ax dot minus ax. First term is multiplied by minus 1. Next term is multiplied by plus 1. Third term is multiplied by ay dot minus ay is minus 1. Fourth term is multiplied by plus 1. Fifth term is multiplied by minus 1. Sixth term is multiplied by plus 1. What is the sum? What is the sum of all these terms? Hey, ax dot minus ax only is the vector thing that I have, which is minus 1. Ax dot ax is 1. This is minus 1. This is 1. This is minus 1. This is 1. So this minus and this plus gets added. This plus quantities dx get cancelled out, right? So dou dx by dou x into delta x by 2 times into delta y delta z is what? Dou dx by dou x into delta x, delta y, delta z plus next to 2 terms. Dou dy by dou y into delta x, delta y, delta z plus dou dz by dou z into delta x, delta y, delta z. Please keep looking at it. Which is equal to what? Dou dx by dou x plus dou dy by dou y plus dou dz by dou z into delta x, delta y, delta z is equal to delta q. That's what I computed till now. What is rho v? This is delta v. Delta q by delta v is, so rho v is equal to dou by dou x of dx plus dou by dou y of dy plus dou by dou z of dz. What is this called as? This is called as del bar dot d bar. Divergence of the flux density. So divergence is what? Limit closed surface integral, limit delta V tending to 0 for the differential volume d bar dot ds bar by delta V, they call it as the divergence. Why are you finding out divergence here? We are finding out the volume charge density at any point. I know that Q is equal to rho V dV. What is that rho V now? Rho V is divergence. Given d bar, we can find out rho V. Once I find out rho V, I have to just integrate one volume integral. I will get the value of it. Is Gauss Divergence Theorem. Let us quickly look at it. Can be revised tomorrow. So I want you to understand this because this is there in electromagnetics as a subject for us. As well, it is there in the topic as mathematics, right? Divergence. Gauss Divergence Theorem is what we looked at today. I gave one d bar. What is that? Quickly tell me. What is the d bar? 2x square yz. Check it. D bar is equal to 2x square yz ax plus 3xyz.
3xyz square.
3xyz squared ay plus
4x square y square z.
x squared y squared z
Az.
is it. What is del bar dot d bar, which is rho v at any point? Differential of x component with respect to x, 4x yz, plus difference of y component with respect to y, which is 3x z squared plus 4x squared y squared is rho v. Now check it. Triple integral 0 to 1 in x, 0 to 2 in y, 0 to 3 in z is the volume. Rho v is 4xyz plus 3xz square plus 4x squared y squared dx dy dz. I took a complicated thing only. What is it now? What is the integral of this? 4 into x squared by 2 from 0 to 1 into y squared by 2 from 0 to 2 into z squared by 2 into 0 to 3 plus 3 into x squared by 2 from 0 to 1 y from 0 to 2 integral dy z cube by 3 from 0 to 3 plus volume integral, triple integral I am doing 4 into x cube by 3 from 0 to 1 y cube by 3 from 0 to 2 z from 0 to 3. That is the volume that we considered. What is the value of it? Two into hey, what is the first integral value? 4 into 1 by 2 into 4 by 2 into 9 by 2. No?
9.
So, what is it? Together 9. 4 into 1 by 2.
Sir, 18
18.
only, sir.
18 only.
Correct, correct.
Yes, sir.
4 by 18, no? This is 18 plus 3 into x squared by 2 is 1 by 2. Y from 0 to 2 is 2. Z cube by 3 from 3 is 9.
27.
27. What about the next integral? Yes. 4 into 1 by 3 into 8 by 3 into 3.
32 by 3.
So 18 plus 27 plus 32 by 3. What is that we were getting?
Same.
18 plus 27 plus 32 by 3. So we used the volume integral to determine the same quantity. Please check things properly because today's class was more of mathematics, but we defined a wonderful thing which we can understand properly is divergence, called as divergence. Rho v is equal to, we proved today, as given d bar at any point, volume charge density at any point is rho v is equal to del bar dot t bar, divergence of flux density. Check it once.